Hi everyone, welcome to the LTM Learning Series. This is Chapter 3. In this chapter, we will explore the need for a reverse proxy, focusing on load balancing and security. Alright, let us get started. So far, we have created the Learning Portal web application on two different servers to allow the public users to access it. Also, we have verified the access from a user machine to both Web Server 1 and Web Server 2, and the Learning Portal web application is working fine on both the servers. Alright, let the users continue to access the Learning Portal in the same way. Is that fine? In this case, why do we need a load balancer? Great question. As you know, the Learning Portal web application is configured in two web servers. Assume the case web server 1 is down due to some technical reason. The same time, user trying to access web server 1. What will happen now? The service won't be available, correct? I know what you are thinking. He may try to access the second server immediately. But how does the user know which server is currently available to serve the learning portal? User cannot, correct? Definitely it creates the uncertainty. Also, this creates learning portal service failure situation. Don't forget, the website is publicly available. It is not only legitimate users who access our website. Maybe some bad actors also access our website. Assume the case, one of the bad actor attempt to exploit our website vulnerabilities and gain control at the web server operating system level, meaning our web server is compromised. This will put our organization into the big risk. Definitely we need a solution for this. This solution should smartly check the server availability and serve the client request to only the available server. Also, this solution should protect our web application from the bad actor. In short, we need someone in the middle between the users and the web servers. This middleman sits between a client and a destination server. Also, this middleman receives and validates the client request to check if they are legitimate or malicious. If it is malicious, the middleman should block the request. If it is legitimate, then the middleman forwards the client request to one of the available web servers. Also, the middleman should receive the response from the web server. Then return the response back to the client. This middleman we call it as proxy. In our case, we are providing the web service to the public users from our web servers. So the web servers are trusted. Anyone can access the website from the internet. So the users are untrusted. Therefore, the proxy should act on behalf of the web servers to protect them from the bad actors. This type of proxy is called as reverse proxy. Let us see how the reverse proxy works. Reverse proxy hides backend server details from the internet. This adds extra layer of security by masking internal infrastructure. Also, a reverse proxy distributes incoming traffic across multiple backend servers for load balancing after checking the service availability. Also, a reverse proxy offloads HTTPS decryption from the backend servers through SSL termination. In this case, the connection from the client to reverse proxy is HTTPS. And the connection from the reverse proxy to the backend server is plain text. In this way, the web servers offloads the SSL part to the reverse proxy. Also, a reverse proxy filters malicious traffic by acting as a web application firewall. This feature is very useful because it prevents harmful requests from reaching to the backend servers. Also, reverse proxy uses caching and compression technique. This technique improves performance and reduces the load on the backend web servers. Hope this helps you to understand how reverse proxy works. In our case, we are going to deploy F5 LTM as the reverse proxy. Since we understood the reverse proxy, let us understand the forward proxy as well. Assume a scenario where an organization has 1000 users accessing the internet. They can download harmful files from the internet, correct? Which could put the organization in trouble. Here, the clients are corporate users and they are trusted. They are downloading the files from the internet, so the destination servers are untrusted. So, we need someone in the middle between the trusted corporate users and the untrusted public web servers. This middleman should act on behalf of the client to protect them from unwanted access and downloads. This is called as forward proxy. Let us see how the forward proxy works. A forward proxy hides the client IP address from the internet. This adds extra layer of security by masking internal infrastructure. Also, a forward proxy restricts users from accessing specific websites, allowing or denying access based on defined requirements. Also, a forward proxy blocks the access to malicious websites. This improves overall infrastructure security by preventing the users from downloading harmful files from the internet. Also, a forward proxy uses caching technique. This technique reduces bandwidth usage and improve internet access speed. Also, a forward proxy provides logging and monitoring features. This is very helpful to track user behavior and network activity. Hope this helps you to understand how forward proxy works. In the feature lab, we will deploy F5 Secure Web Gateway as the forward proxy. So, the summary of this video is there are two main types of proxies based on traffic direction and purpose. If the traffic is outbound, the trusted clients connect to the internet. In this case, we need a forward proxy to act on behalf of the clients and protect them from unwanted access and downloads. If the traffic is inbound, untrusted clients connect to our trusted servers. In this case, we need a reverse proxy to act on behalf of the web servers and protect them from the bad actors. This concludes our chapter 3. Please continue watching chapter 4 to understand how the F5 LTM operates as a full reverse proxy. Thank you for watching.